continue our discussion of color, we need to look at color models. Color models are ways that we use to express different colors, and they make a big difference in how we think about color and what we can do and what we can accomplish. So let's launch off into this. Our major color models are the following: RGB, which is red, green, and blue; CMYK, which is cyan, magenta, yellow, and black; and HSV, hue, saturation, and value. RGB, that's the way our eyes work, that's the way screens work on televisions, etc. CMYK, that's paint, print. Anytime we want to make a physical color on an object, we use CMYK. Hue, saturation, value is the easiest way for people to think about it. So when we do design work, we do hue, saturation, value, or there's a variation called hue, saturation, lightness. That's what we're going to do in color models. So let's start at the beginning with the red, green, blue, and it's easiest to start with the color wheel. So what we've got is at the top of the color wheel, we've got red, green, blue, okay, and blends of these. So if you blend red and green together, you get yellow. And if you blend green and blue together, you get all these turquoise values in between here. And between blue and red are the purples. Okay, so this is your basic color mixing. We're actually going to come back to this again because around this circle is what we define as the hue. And we'll want to talk about hue again later. So basically, remember from your eye anatomy, you've got red cones, green cones, and blue cones. They can each receive and sense particular wavelengths of light. And that's how you perceive color. That's why we use the RGB color system. Now, since red, green, and blue is actually a three-dimensional rather than a two-dimensional thing, it makes interacting with color somewhat problematic. So here we see a RGB color picker. This one I clipped off of Photoshop. And what they do, they're actually giving you a lot of different ways of expressing your colors, and the one I've got right now is I said I'm going to take red and I'm going to put it right here. So this is lots of red, 255, and this is no red, 0. Over here then, what we're going to do is we're going to have this axis right here is blue, and this axis is green. So what we see over here is these little sliders up here say I've got lots of red. Alright, good, lots of red. If I've got lots of red, then, and I've got lots of blue but no green, so low green, high blue, then I'm going to get that magenta that you see here. Right up here, I'm going to have lots of green, lots of blue, and lots of red, and it's going to come out white. Over here, I'm going to have almost no blue. This is 0 in the blue axis, and 255 in the green axis, and I'll get yellow. So the way these color pickers work is you pick what you want to be in this control, and then they give you a two-dimensional layout for the other two axes, and you can pick a color, and they show you right here what the color is. Okay, that's an RGB color picker. Here's that same color picker, only this time we've said there will be no red. So we pulled from maximum red down to no red. Red's down to 3 here. And then what we get is we get all these various combinations of green and blue. So there's no red. So here's lots of green. Here's lots of blue. Here's mixing them together. Here's no green, no blue, and no red. So we're going to get a black down here. Okay, it's a basic color picker in RGB. We like RGB because that's what our eyes see, and that's what our screens, our computer screens, generate. So when you're working on a computer screen, it's going to be RGB. Okay, now one of the things, a concept you need to understand is that RGB is an additive color scheme. So basically what happens is if I've got red light plus blue light plus green light, the result will be white. Okay, the colors add together. So yellow is green plus red. What's happening is when you sense yellow is your green receptors are being stimulated, your red receptors are being stimulated, and your brain says, oh, I have both of those, it must be yellow. This one says all three, red, green, blue, cones, are being stimulated. So that's the additive color scheme. Red, green, blue, you mix them together, you get white. Alright, now we want to talk about a different color scheme. This is the subtractive color scheme. This is the colors you get when you take color out. So instead of starting with black and adding in colors, we start with white and take colors away. So, for example, if we remove if we remove red, so here's red up here, this area right here has green and it has blue, but it has no red in it. Now that's cyan. If you take out the green, then you only have red and blue. That's magenta. If you take out the blue, so all you have is red and green, you get yellow. So that's the cyan, magenta, yellow color scheme. Cyan is we got rid of the red. Magenta is we got rid of the green. Yellow is we got rid of the blue. Okay, this is the way pigments work. So here we've got all these cans of paint. The yellow paint right here, the way it functions is the molecules of the paint absorb red light. So when light shines down on this paint, bing, the red light stays, get converted to heat, but the blue stays, and the green and the red get reflected, and your eye says yellow. Okay, over here, this is a blue. So what it's doing is absorbing both red and green to get that pigment. You're absorbing both red and green. Okay, here is a sort of a light blue, just like this one here. What you're doing is you're absorbing some red and some green and reflecting all the blue. Makes for a lighter looking color here. Here's an orange. Okay, this orange is going to be reflecting all the red, absorbing a little bit of the green, that's what gives it, and then absorbing all the blue. Okay, so that's the subtractive color scheme, cyan, magenta, yellow. Now, the problem with cyan, magenta, yellow was the problem we encountered when we did in 3rd grade when we were playing with our watercolors. And that is, if you mix all the colors together, which most of us did, you don't get black. When you mix them all together, you get a muddy, dirty, sort of weird brown. So when we actually do printing, we use the cyan, magenta, yellow, and then they add black. So they actually add an ink that's designed to be black, so that when you get your blacks, they're pure black and not sort of kind of an almost black, kind of a muddy brown. Okay? That turns out that when you're printing, cyan, magenta, yellow, and then get the black in there to get a good clean black. So that's what you're going to see for printers. Cyan, magenta, yellow, black. CMYK. Alright, let's go back. This is our original color picker from Photoshop. Notice right over here, right down here in the lower right, is the CMYK. So for that color right there, almost no red, medium green, medium blue, then what we're going to get is lots of cyan, a little bit of magenta, a little bit more of yellow, not very much black, it's not very dark. If we were to go down here, for example, then we get a lot of black over here. This is just telling the printer, give me lots of cyan ink, some yellow ink, less magenta ink, and a little eensy bit of black ink. That's the CMYK. We almost never design or work in this space, but we need this to be able to print. Okay, let's do hue, saturation, value. This is the most popular one for actually doing design. So the hue, this is in our Photoshop, and we said let's put the hue on this thing here. So there's the hue. Starts out in red, goes through yellow into green, goes through all those turquoises into blue, goes through your purples and back into red again. So this is 0 through 360. It's a color wheel, if you remember our color wheel from a minute ago. Okay, once you pick a hue, this one's picked, then that's established the hue, and what we get is on this axis is the saturation, and this axis is the value. Okay, let's start with saturation. This is high saturation. This is low saturation. Saturation is how much color is there. So lots and lots of color, it's white. No color at all. Okay, the same is true down here. Lots and lots of color. This is going to be a pretty serious turquoise, and over here it's going to be gray. Now, this axis is the value. Bright, lots of light, dark, no light. That's the value. Okay? Value is extremely important. This is where we're going to get our contrast. This is what our periphery understands. This is a big design. We want to understand value. Okay, so what this says, so up here the value is high. So we went from a bright blue to a white. Down here we went from a dark turquoise into black. And down here, when the value is so low, you can't find the color anymore. It's just all black. All right. Hue, saturation, how much color, value. This is the one we're going to use for all of our design work. Now, the nice thing about Photoshop is it actually shows you what all of them will be. So we're working in hue and saturation. It's also showing us the RGB, showing us CMYK. I never mess with the lab color. Okay, so here's a slight change. What we said this time is we're going to hold value or brightness on here. So light to dark. Okay, here's the hue going across this way. Going left to right is a hue. Red through green through blue through back to red again. Round the color wheel. And the saturation is going this way. So notice lots of color blending down into gray. It's a light gray because the value is medium high. Okay? Hue, saturation, value, we're just looking at it different. We're saying instead of controlling the hue over here, we're going to control the brightness, and then we can select the hue and the saturation as we want. High saturation, low saturation. Red through green through blue through red again for the hue. Here's the brightness. Very bright, very dark. Hue, saturation, value. Sometimes we use the term value, sometimes we use the term brightness. Now, this is from Microsoft Office. This is their color picker. It's different than the Photoshop color picker. And they use something called hue, saturation, luminance. It's very, very similar to what we just saw. So here's our hue. Red, green, blue, back to red again. Here's our saturation. Bright, lots of color, down to gray. Now, this actually works a little different. Notice up the top here, what we don't have is bright, bright color. What we have is white. And then down here we have black. So what they're doing over here is we're taking the color I selected here and blending it towards white or blending it towards black. This is actually a nice color picker for a lot of things we do when we design color schemes. It's a variation on hue, saturation, value. But not quite, not exactly. Okay, color models. Red, green, and blue. This is what our eyes use. This is what our screens use. CMYK, cyan, magenta, yellow. This is subtractive. So we're cyan, we're absorbing red. Magenta, we're absorbing green and reflecting everything else. If you mix them all together, you should get black, but you don't really get black, so we add black on there to get that right. This is for paint. This is for printing. Hue, saturation, value. Remember, hue is which color is it? Saturation is how much color. And value, bright or dark. Hue, saturation, value is the one we're going to use for design. That's the one I want you to really pay attention to. Okay, there's your color models. Good designing. Have a good time.